Time. Okay. लोअर तक कवर अप करना पड़ेगा आपको, ट्राई करो।
हाँ दो बार कोशिश करता हूँ। Now come with the programming languages. What the programming languages we have? We can see over here the historical perspective, traditional programming concept, procedural units, language implementation, object-oriented programming, which is called OOPS, object-oriented programming system, programming concrete activities, and declarative programming. These all are the programming concept or programming ways which we follow. And object-oriented programming, it is the latest one what we follow nowadays also. So all the after C++, I mean it is C++, Java, .NET, and now the some ERP programmings are also working on the OOPS concepts. The generation of the programming languages, which is very important. From it is started from the first generation, then second generation, then third generation, then fourth generation. These all the generation perspective. Initially, if we start with the first generation, the problems solved in an environment in which the human must conform to the machine characteristics. Initially, we have to think about the machine characteristics in the first generation language. Then it comes to the last generation, problem solved in an environment in which the machine conforms the human characteristics. So initially we have to think about the machine perspective. Now what we are going to give the instructions, machine has to follow like that. It is the, I can say, bifurcation from first to fourth generation. The second generation assembly language. This is a second generation assembly language, a mnemonic system for represent machine instructions. Mnemonic names for OP codes, identifier, descriptive names for memory, location chosen by the programmer. It's all things done by the programming second generation. It's assembly language, which is nothing but the machine level language. Initially the first level language, first generation language, then second generation language, these all under, it's called machine level languages. What I have asked you about the mainframe, these all the initial first generation and second generation languages, which is very very tricky to understand, very difficult to write the code for that. These all things come because there is that time it is too difficult to understand the concepts, to understand write the code. Those days it is very difficult. So it is initially we have to give the instructions to machine to represent our what I can say instructions. Then assembly language characteristics. What are their characteristics? See, it's one-to-one correspond between machine instruction and assembly instruction. Their programmer must think like a machine. What the machine what the machine can do. On that way, we have to. A programmer or developer has to think. But in fourth generation language, what the human think, machine have to do like that. What we are thinking, machine can do. But that time, we have to think according to the machine level. Inherently machine dependent. I can say that yes, this is true. We are dependent on the machine. Now we are not dependent on the machine. Converted to the machine language by a program called assembler. Just like compiler, what we have talked about, interpreter. Then it's assembler. Assembler, what will do? It will convert the machine language by the program. It will convert the machine language by a program, which is called the assembler. The third generation language. It's use high level primitives similar to our pseudocode in pseudocode. Machine dependent. Mostly example Fortran, COBOL. These are the example. It's machine dependent. These are the examples of third generation language. Fortran, COBOL. Each primitive corresponds to a sequence of a machine level language instructions converted to machine language by a program is called compiler. See, initially we have learned about the assembler. What assembler will do? It convert the machine level language to the program. And what the compiler will do? It will convert the machine language by a program. It will convert. It will not convert. Convert to machine language. It will convert to machine language by a program is called the compiler. To understand the concept between compiler and assembler. Compiler basically comes in the third generation language, but till second generation language we are using assembler. Then evolution of a programming paradigm. See, from 1950 till 2000, we can see that the evolution of the languages. Initially, it is, if you we can see that there is a machine and languages. There is a machine and languages. So initially the languages which is in 50s, then Fortran, COBOL, ALGOL, BASIC, APL, BASIC, then Pascal, Smalltalk, Ada. Ada come around 1980s. 1980s. Then we can see that ML Scream, Smalltalk. These all languages come in 80s. C is also started in 1970, but it is not in that much fluency have in the C language which will start in the C. There is a very few concept in 1970 has come, like there is no concept of I can say that pointers or that time, and some other also there is not the concept of initially has that what you call that there is something which is not completely I can just see, but initially when the day by day or year by year it will grow, and in 90s we found that C++ which is come with the OOPS concept. So initially then after that in 90s we can say that the OOPS concept, object oriented programming concept, has started. So we can see that in C++, then Java is also the object oriented, have an object oriented programming concept. Then we have a Visual Basic C hash, Visual Basic C++, which is also come. C hash is nothing but the C sharp, what we call nowadays. It come in the 2000. Between 19 and 2000 we can see that in Visual Basic we have a Java, we have a C sharp. These all the object oriented concept languages. Smalltalk, C++, Visual Basic, C hash, Java. These all the imperative language which is called from Fortran to Basic, C, Ada. Ada is nothing but algorithm which is called Ada, algorithm and design. Then declarative languages which is GPCC's Prolog. These are the declarative. So we have bifurcate the languages in the form for declarative, imperative, object oriented, and the functional. Nowadays what we are nowadays in 2000, I mean let's say 15, after 2010 or 2000 we are using basically the object oriented programming concept, not even the C++, Visual Basic, C sharp, Java. In ERP side, if you are looking for the ERP side, also we are using the same object oriented concept. Then we can come around the function, a function for checkbook. Checkbook balancing instruction from the simpler function. Here I have taken example, simple example how checkbook is work. Just like we have given the input. So there is a old balance, credit and debits. So old balance and credit we have to sum whatever the old balance is there in your account, and we have credit that find sum, and we have debit where find sum, and we find the difference which is a new balance, your output what exactly is doing in a ledger account. So I mean to say, so whatever ledger is doing, to replicate these things in the programming concept, we follow this instruction. This is called the instruction. These instructions might be just like what happened. Some of the banking system, I can say, I can give you an example of state, some bank, just like in India, State Bank of India or some other banks. What they are doing, they want some software which can easily handle these things. But initially days in my Windows, when the bank has started, they don't have a my Windows IT information technology concept. So for every customer, they have to maintain one account. Just like in bank, what exactly happening? For every customer, they have to maintain one account. In just like my name is my name is XYZ. For XYZ, a bank, State Bank of India, maintain one account. So whatever the transactions is going on day to day or weekly or monthly, so they have to maintain that account in a ledger book. But initially, there is a one physical book in which they have maintained those accounts. So when the technology has come, so the banker is also thinking why we can take the help of those technology and we can create some software with the help of these calculations, day to day, my mean to say account related calculation, ledger related calculation we can do. So they have they have given the instructions to the my Windows software organization or software developer to create one software. With the help of that, they can easily I can say check the accounts of each and every one. So this is the concept they have given to the a software company, and their developer has created one software. With the help of that, they can easily know at the end of the day the balance in each and every entry of particular my main to say account holder. So this is the concept basically behind that. Then composition of a typical imperative program or programming unit. What we have talked about the program. This is the program called. The first part consists of the declarative statement describing the data that is the manipulated by the program. So there is a two part. We have bifurcated the program in a two part. First part is tell you about the description of the program. When we are writing some programs, so initially we have bifurcated the program in the two parts. So first part will tell you about the description, declarative, description of the program, and the second part consists of the imperative statement, describe what the action we have to perform. First part we write about the description what we need to do, and in the second part on that description what we need to perform. These things we can bifurcate, we can segregate these things in each and every program. So I can show you the brief chronology of each and every languages on their my mean to say early comings. Just like if you start in the 50s, we can see that there is an order code which is primitive assembler. Then in 1957 we can see then the Photon has come, which is high level programming language. Then Algol, then Lisp, COBOL, APL, Simula, Basic, PLIL. First modern functional language is the Proposal. Then Prolog. In 1972 the C has come. It's a system programming languages. Then Pascal, Scheme, CFP, Smalltalk, Ada, OOPS. So in 83 OOPS has come. 1983 or 80s OOPS programming, object-oriented programming concept has come. It's a reinvented. Then C++ OOPS reinvented again. Then some Mathematica, other language. Then Perl, Ruby. We have a JavaScript. Then Java. In 1995, OOPS is reinvented in the internet. Actually, in 1995, we can see the internet come in the picture when the OOPS object-oriented programming concept is reinvented, and the C# or C# we can say in 2000 has come. This is, I can say that the chronology of each and every year wise, how the program languages has come from 57 to 2000. And after 2000 there is additional changes. Just like in Java, there is some additional changes has come. They have a struts, they have a Hibernate. Each and everything is additional nowadays in Java. They have adding the different concepts to, I can say, make a good GUI, graphical user interface. Basically Java, main of the time it is used for, I can say that it's an internet language. Web-based languages become a web-based language. So most of the time, whatever the web-based related work we have to do, basically we are using Java, C#, these languages. So it's become a web-based languages nowadays. Then what is a programming language? It's a kind of set of commands a computer has to taught to understand. Languages look like machine code for use for writing games, writing application programs like Excel. See, Excel. Excel, what we have taught in last days, Excel is also, it's a program, nothing but it's a program. Program is running while we are opening Excel and we are writing something. If we are adding, so there is a background, one program is running for that. So when you are writing, when we are adding two numbers, just like 5 to plus 6, so there is a background program. When we are writing 5, it will create one line of code in the background. When we are writing a 6, it creates one line of code for adding these all, whatever the job we are doing in the Excel. For each and everything, there is a program running behind that. We can write a game. We can play a game while we are writing some codes. With the help of that, we can create one game. Other high level example, hello, whatever. If you run logo, JavaScript, many more. So we can do a lot of things with the help of coding or programming. What does programming looks like? See, there are some examples of an instructions to print word hi. If we want to print word hi, so there is a lot of way we can write. Just like in logo, language logo, PR hi, JavaScript, we are writing alert. Then bracket, double quotes hi, then double quotes close, then bracket close, colon, then Fortran we are writing print hi, basic, the same way basic and Fortran, then COBOL display hi, simple. See the difference you can see that initially we can see in Fortran we are writing print hi but in double quotes, but in COBOL we have to write in a single quote. Then C++ we are using the command printf for same hi. Then in Pascal we can write ln language a hi. Then assembly language, this is the assembly language, xprint message1 dc hi. So this is the way we can print a single word. It's like hi, we have to print hi or hello, whatever. So this is the way we have different programming concept. With the help of that we can write a single word hi. Then how do you write a program? This is very important thing. See, actually when you got one instructions or you got some I can say that especially the instructions from your guideline or instructions from your user or customer that we have to write a program to create a calculator. I'm taking the same example. So they have given you the instruction to write the calculator. It is they want a single digit calculator or multiple digit calculator for that. So they have given you the task for that. So decide this. Then you have to decide the steps. What the steps are you going to take to write that program, and write the steps in a pseudocode written in English or as a flowchart graphic symbol. See, there is a two way to write those instructions in your own way. Either you can use a pseudocode just like a simple English language, and or second you need to write a flowchart which is graphically defined, graphical symbol, then translate into the programming language. Those things you have to write in a programming language, try out the program and debug it to fix the necessary. Debug is nothing. What here we have seen the word debug. What is exactly the debug? See, actually what happened when we are writing a program, so it is not necessary when in a single first time you will get a desired result. Might be there is some issue when you write the program, it will give you some error. So at that time we have to go inside a program and we have to check where we are getting this error, from which line or from which code we are getting this error. So these process, when you're going to inside a program to find out the error, so this process is called debug or debugging. This process is called debugging, entire process. So this is called debugging. So this is debugging process you have to follow. See, I have asked about the pseudocode, how to write the pseudocode. So here I can show you how to write a pseudocode with a simple example. Just like if we have to write if we have to write about pseudocode. See, if we have to write, suppose one program, calculator program, an example, write calculator program. So for write, we have to write a pseudocode. How to write a pseudocode? First step, what we are thinking that how to write a pseudocode. See, in the calculator, I am taking four functionality: additional, multiplication, multiplication, subtraction, and division. So first, I will take addition. So in addition, add two numbers. Second, this is a simple pseudocode what we have to write. This is a simple pseudocode. It's an English language what we have taught you about. It's a simple English language. Then second, addition, then subtraction. If you want to do subtraction, then what we are doing in subtraction, we need to write those things. Subtract two numbers. This is a simple English language. This is called the pseudocode, and every developer, every programmer have to write this pseudocode. This is called the estimation. Before writing a program or code, we are doing the estimation. Estimation in the sense how to write a code according to the given instructions or given inputs, according to the given inputs from the user or from someone else. So we are writing a pseudocode. In a pseudocode, we are using a simple English language so that you or someone else, if you are not able to do, suppose you are busy with some other development, so at least some other person easily understand with the help of your English language what need to do. This is called basically the estimation. We are doing the estimation, and then pseudocode writing. I mean, the pseudocode writing is nothing but the estimation. After estimation, you have to calculate time. How much time you will take to implement that code or instructions. These things we have to do. This is called pseudocode. Understand? Then we are going to what is pseudocode. This is all in pseudocodes. List of steps written in English, like the instruction of a recipe, must be in the right sequence. Imagine like bake the cake and then mix it up. It's a simple English language. Imagine saying make the cake and then mix it up. So I have to add two numbers. So take one number, take another number and add. This is simple pseudocode. Each and every step should be in English. All the instructions should be followed properly, so that another person who are not going to do if you are not going to do your development or implement, so another person who is going to that your pseudocode easily understand. The sample of pseudocode: add two numbers, pseudocode is start, get two numbers, add them, print the answer, end. This is simple pseudocode. Start pseudocode. This is simple pseudocode for two numbers. I have written over here also. Start, you get two numbers A and B or 1 or 2, add them, print the answer, and end. This is a simple pseudocode in simple pretty English language. Then how does I have told you about two things. One is pseudocode, and second thing about the flowchart. Pseudocode we have done. How to write the pseudocode? Easy, understandable. Then second is how does a flowchart look like? This is the flowchart which is look like. The pseudocode from a previous slide would like this as a flowchart. If you want to, I mean to say, these pseudocode had to convert into the flow chart. So how will we convert? Start, get to numbers, which is here, get to numbers, then add them, then print answer and end. This is a simple flow chart of that pseudocode. See? Simple flow chart. Start, then add two numbers, add them, print the answer, end. Simple. Whatever the pseudocode we have written, the same things we have to follow in the flowchart also. So there is a very little difference between the flowchart and pseudocode. Pseudocode we are writing a simple English language, but in a flowchart we have to give them a symbolic representation. That's it. What are these funny symbols? See, this is the start symbol. This is very important. Start or end symbol. You can see start and end symbol. Both. Then input or output. For input and for output. These two. Get to numbers or print answer is output or. So we are taking this. Then process means what your functionality. Add them. So we are using add. And decision we are using this. Decision in the sense, I will let you know. Decision in the sense, sometimes we require, if the number is greater than 50, then only I require output. If the number is less than 50, then I only require output, like that. This is the decision. We will we'll go through this in the next slides. What are the funny symbols? Just like start end. This is a start or end symbol used to beginning at each of the flowchart. If you're using a flowchart, then this symbol have to use each and every time while writing your flowchart. If you're not using your flowchart, if you're using a pseudocode, then do not need to use this. But if you're writing a flowchart, then it is necessary to use this. Use the beginning at each of your flowchart. And this another one is input output symbols. Shows when the information data comes into the program or it's printed out. See, input output program, get to numbers. My mind is input. Whatever the input we need to put while we are adding two numbers. So this is the input output. My mind is at the output, when we are going to print the program, then the same symbol we have to use. And when we are going to give some input, then also we have to use the same symbol. Then process in the sense what the function we have to perform. So here we have to add two numbers. So for adding two numbers, we are using this. Used to show calculation, storing of data in variables and other processes will take place within a program. This calculation and other activities, whatever we perform in the program, we have to use this symbol. Then decision. See, decision I have told you about. See, there is a decision used to show that the program must decide whether the something, usually a comparison between two numbers, is true or false, yes or no, or true or false. Branches are usually shown. See, these two branches have been shown, y or n. Y is yes or no. See, they have given the instructions. If x is greater than 7, if it is true, then it is go here. If it is false, then it comes here. The same way we can write the pseudocode also. But here, if we have using the symbols, that's why we are showing over here. Otherwise, the same thing we can follow in the pseudocode also. Another same example in the pseudocode. See, the same thing I have told you about. See, start, get your born, calculate age, print age. If age is greater than 50, print old, end. This is a simple pseudocode to write with decision program. I mean, the decision comes over here. You understand from here, print age, you understand. But for if age is greater than 50, then only you are old, otherwise you are young, like that. This is a decision making thoughts, decision making line. Here, how it is shown over here, the same thing shown over here in a pseudocode form. Another sample calculating age. What we have done here, it's a pseudocode for calculating it, and it is a flow chart. Start, get year, which year you born, calculate your age, then print age. If your age is greater than 50, then old, otherwise end. It will come also end over here. If your age is greater than 50, then it will show you old. It will show you output in old. Otherwise, it will show you no, n, whatever you want to type. This is like, I will show you the example. Simple example, pretty simple. Suppose I have written the calculation over here. So I will write over here program. Just don't confuse. If result is greater than 20, 9, 18, 19, 19, if result is greater than less than 19, the show result, then is write fail. What I have done in this program, the same thing. Initially what I have done, I have added the two numbers, which is, I think you understand. Then after that I have used if result is less than 19. Why have used this less than 19? See here I have taken I and I basically is a one character. So one character is till 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Till 9 it's a one character. After 9 it becomes 10, it's a two character. So 10 plus 10 is 20 and 10 plus 9 is also 19. So maximum 9 plus 9 we can add. 9 plus 9 is 18. So if the result is less than 19, less than 19 means still 18. Less than 19 means still 18. Then show the result. Else is what we'll do. Else means it will show you if the result is not less than 19, then type results. So whatever the result it is there, you just type it. Else means if it is not correct, then write fail. Then you have to write fail. My Windows program has failed. So it's come out. The simple and pretty simple language. This is the simple language what I have shown you, whatever it's written over here. The next, elements of a program. So all programming language has certain features in common. All the programming language, whatever you are using, C, C++, Java, .NET, C#, C#, SAP ABAP, whatever. These things are common. Variables, command syntax, the way commands are structured, loops, decision, functions. Each programming language has a different set of rules about these features. Variables. What is variables? Variables in the sense what we are going to create, just like in our example, these two A and B is a variable. It's a variable. It can vary. Variable is which can vary. It's maybe 1, maybe 2, maybe 3. These are all the variables. Then second thing, then variable, then command and syntax. Command and syntax, what we have written here, it's a syntax kind of thing. Syntax. It will check you the syntax. There is no syntax here, then it will completely go over there. Then we have a loops. We are not using any loops. Decision we are using. Basically, the decision is like if result is less than 19, this is nothing but a decision. Loop is like, I can say that it will go like this, and there is, we have writing like loop which is go one by one. Inside, if you are written in this loop, and if you're going to give here in loop, so it will go inside a loop. It will again calculate, 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 calculate till the time it will not finish. It will like a loop. This is called a loop. Then we have given a decision, then functions, what the functions we are going to perform, that's we have written over here. These all things common, these all things are common in each and every program. Then variables. Variables are part of almost in every program. A variable is a place to put data and is usually presented by a letter or a word. Think a variable as a Tupperware container which labeled on it. Variable name cannot contain spaces. Some programming languages have very specific limits on a variable name. Variable name, what we have shown you. Just like I have to add two numbers, then A is a variable, B is a variable, result is also a variable. These all the variables. Variables usually are several ways to put information into a variable. The most common way to use the equal sign. X is equal to y plus 7 means take the value of y, add 7 and put into the x. See, these all two are variables. X and y here are variables. X and y are the variables. Count is equal to count plus 2 means to take the current value. It will take the current value of count, it will put over here, and it will put these two into count. So it will go in a loop and or add 2 into it and make it into a new value of count. Just like I have declared upper side, count is equal to 5. Then 5 it come over here, 5 plus 2 7, then 7 become put here, then 7 become a new count. Then 7 plus 2 9, so it will go over there 9 again. 9 plus 2 is 11, then again it will go like this loop. It's a kind of loop kind of thing. It will completely rotating. Then another variables we have, sometimes you must specify the type of data that will be placed in a variable. Here are some example of the data type. Data type is also nothing but a variable. It's like numeric, string is nothing but text, integer which is a whole number what I have given you, I, it is symbol is I, n, long large number, boolean is a true false, 0 1, boolean is nothing but a 0 1, true false. Then variables may be classified as a global or local. In every languages variable classified as a local variable or global variable. Global variable is one that can be shared in all the programs including any function or subprogram. A local variable is one that is used only within a certain part of the program, for example only a function or a subprogram. See, there is two things you need to understand here. Variable is a two type, global variable and local variable. What is global variable? When we are writing one program or one source of code, so we are declaring some variable in the starting which is used inside all the program. So that is called a global variable because that variable is used in entire program. Then another thing come on about the local variable. Local variable basically we are using inside one code or one function, one part of the code, not entire code, one part of the code. So that variable is used for that particular subprogram or for that particular function only. So that is called the local variable. Then command or syntax. See, programming languages are truly languages. They have rules about grammar, spelling, punctuation, etc. You need to learn the rules of a programming language just as you learn to speak and write English. If you have done some mistake while you're writing your program, I mean to say grammatical mistakes or punctuation or comma, you have not given exclamation mark, so it will give you a syntax error. There is an error which is called a syntax error. So it will give you one syntax error. With the help of that you can identify this is the syntax error. So while you're debugging your program, you have to check out where we are getting this particular syntax error. Either you have done some spelling mistakes, either you have done some grammatical mistakes, either you have done some punctuation error. So these things you have to identify while writing a program. This is simple English language grammatical language which we need to follow while we are writing the program. Then loops. What is a loop? What exactly loops? How we are using a loop? A loop is a repetitive or all or part of a command in a program. Loop is nothing but a part of the program in a program. When we are writing some subprogram or some source of code inside a loop, so that will continue working till the time it will not finish what I have shown you right now. Loop often has a counter or a variable and continues to repeat a specific number of times. If we have written the counter, if we are using the counter that it loops has to go till 5 times, then it will loop only 5 times. The loop may also continue until a certain condition is met, file or until number reaches a set limit. See what happens. Loop will work till the time you will not get the desired result. When you will get the desired result, loop will automatically stop. So basically, where the loop has used, see, suppose there is a data about 1 lakhs of data. So at that time, what the programmer developer will do, if you find any particular record and that record is somewhere between the lakhs of the program, it has been suppose 59,998 lines. So how you will reach over there? So for that we have using loop. So whatever the loop will do, while going from first line, it will go line by line, and when it will reach on that particular line, 59,995 line, it found the result, it will show you the output. After that, it will not go till 1 lakh line. If found it, it will show you the output. It will not found at 59,995 line. It will again move and it will search for your the particular record it's looking for. It will look for that record till the time it will not find out. This will exactly the loop will do. Then decisions. I have shown you the decisions. You saw a flowchart symbol for the decisions. A program often needs to decide whether something is true or false in order to see which way to continue. Absolutely. If you want to, there is a two-way. If you are writing some decisions, there is a two. Either it is true or either false. There is two things in a decision, either true or false. Yes or no. That's it. So we are basically using if then or if else. If then else. If then or if then else. Program often use if. What I have used if and else I have shown you over here. So if then or else if then statement are showing for the decision. If age is greater than 50, show old. My mean is a print old. Else print young, like that. As simple as. This is the decision making. Then if a statement always has a condition to check, often a comparison between a variable and a number. What I have shown you, if a statement, when you write the if a statement without any condition, you can't write the if a statement. Only if it is not possible. You have to write some condition over there. If with some condition and then your statement. If a statement also must specify what to do if the condition or comparison is true. Yes, obviously. If you are writing the age is greater than 50, then what to do? You have to write old. Then you have to print that old, word old. These instructions for true may come after the word then, or they may be simply be listed. If, then, else, like that. If then statement when the condition is false, the program simply ignores the then command and continue with the next line. If you find that if condition is satisfied, then it will not go to the next line. It will print the result. If the first statement is false, whatever the decision you have given, if it is false, then it will go to the next line, then it will print the next, then whatever you have given. Just like if age is greater than 50, then print old, else print young, like that. If it is not find greater than 50, then it will go to the else command. Else command will show the what it is written in else command. It written print young, so it print young in the output. As simple as that. Then functions. What is a function? In most programming languages, small subprograms are used to perform some of the tasks. So in most programming language, what happens? There is a simple code have written. There's a huge program, some bulk program has 1000 or 5000 line of codes have written. So there is a set of codes, small subprogram has written in each and every, I mean to say, after each and every 100 or 200 lines. So this is called the inside that there is a function, subroutines, handlers are there. Inside that there is a function is there, subroutines are there. Function often named, example, net, get name, calculate text, like that. They have the functions. There are different kind of functions. If you want to calculate text, you want to calc text, then calculate age, calc age. Then different kind of functionality. Get name, you want to, whatever name you want to give, you can give, and inside that function you have to perform certain tasks. A function generally get information from the main program, perform some task, and return information back to the program. Functions follow the same rules of syntax. Example, as a main program, JavaScript code is primarily made of a series of functions. See, function basically what will do, it's a get the info. See, you have written the main program and you have written some functions. So function what will do? Function will get the data from your main program only, main program only as a written, and it will show you the output. Most of the time, JavaScript, the primary made of a series of a function. It will take the most of the time JavaScript. I don't think so over here. It will JavaScript which is responsible for most of the time. I mean to say, lot of the functionality have used in the JavaScript. JavaScript not there. Most of the time, most of the functionality has been used in the JavaScript. So JavaScript is the kind of language which is used most of the functions. Hence, for writing code, how to write a code, which it is given you a hint. Code means writing a program in the appropriate language. What is code? Code is nothing but to write a program to an appropriate language. Code is nothing but instructions. In starting, I have told you code is what? Code is the instructions. Code is a program. We can write code is a report, instruction, program, whatever the way you want to nomenclate, you can nomenclate. There's no issue at all. Be sure that the code is exact, spelling, capital and lowercase, punctuation, etc. See, what happens in some of the language, if you're not writing the some word in a capital language or capital words or lowercase, it will show you the dump or error. It will show you the error. Definitely it will show it because it's a case sensitive, which is called case sensitive. Some words are case sensitive in each and every program. So you have to write those words in a capital or lowercase. Otherwise, it will show you the error. And if you're not using any spelling, if you have done some spelling mistake, you have done some punctuation mistake, then it will show you the error. So these things we have to know while we are writing the program of the particular language. Write part of the code, try it, then write more. See, the way of programming is what? Initially, if you want to write, if you have big instructions to write a code, so you have to write small code. Initially, you can, it's like if you want to simple. I'm giving the example. If you create a calculator, so first you have to write a code for adding addition. First, you have to write the code for addition, then subtraction, then multiplication, then division, then other things, whatever you want to you require in a calculator. So this is the way. If you are going to write each and everything once, so while you are executing the program or while you running the program might be to get the error, so it is too difficult to find out your error while debugging, I can say that, because it's become so lengthy program. To find out the exact results, you will get time, it will take time, and it will take lot of up and down to you to find out the error and to get the end results. So better when you're writing a code, write a small code and check them, execute them, it will proper work. Then again you start writing code, which is called proper way of programming, which is written over here. Then debugging. To debug means that try a program, then fix the mistakes. Debug is nothing but while you are writing a program, then if you find some error, debug means nothing but error, then you have to fix that error. It's very important, or mistake. Virtually no program works the first time you run it. There are just too many places to make error. Absolutely right. When you're writing the program for first time, it is not necessary that when you're writing the program, it will run properly or perfectly. So you have to write, you have to check the errors, you have to follow, you have to debug it, you have to fix the error, and day to day when you're performing these activities, you become a perfect. So while minimizing the error, so those things you have to keep in your mind, that here we are getting error last time, so we have to do like this. Sometimes what happens while declaring the database or variable, we are doing some mistakes over there. So initially we are getting the mistakes, obviously we are getting the error. We have done mistakes, so we are getting the error. But the future, when again we are going to start those things, again we are writing some code or we are writing the same program, those times we have to take care from your last mistake, that while declaring the variable we have done these mistakes. So for overcome those mistakes, you have to you have to debug, and you have to do lot of exercise for this. When you're debugging a program, to look for spelling and punctuation error also. Absolutely right. When you're debugging a program or we are writing a program, take care of these things, spelling and punctuation error, especially spelling. If you need to write a printf, is a function, if you written print, so it will give you the error. So always take care of those things. Fix an error at a time, then try to program again. Absolutely right. You have to fix your error in a given time period, because when the instructions are given from your customer or some user that I need to write, I need these things in a certain period of time. So each and every moment, each and every hour, each and every minute is important for you. So when you're writing a program, try to write the program in such a manner that you will get a minimum error. You will get the minimum error, so that you can you can deliver your task in a certain or given period of time without error or without full flesh, so that when it will move, it will go to the user, so he is also happy with your performance and pleased with your performance. Then self-check. There is a computer program with series of instructions to accomplish something. A TV show written in Egyptian hieroglyphics can be written any way you want to. Self-check. There is one thing where you can do while writing a program. There is two things. As a junior, while you are writing a program, there is initially you are checking your code, and second thing, I can say that your superior or your senior going to check your code. So review, that is called a review. So they will review your code. You think that I have done everything is perfect, but there is still while you are writing some code, there is some instructions need to follow for each and every language. So those things we have to follow. If we are not going to follow that, it will not give you error, but basically we need to follow those instructions what is given by your superiors or your seniors. So basically you have to first self-check that I have done each and everything is perfectly okay or not. If you think that it is perfectly okay, then you can move this code or given this code to your superior to review check, which is called a review check. Then they will check there their side, and if they found everything is okay, then it will go for the test. Basically, you will do first test, then your reviewer will do test, then it will go to the tester. Tester, my mind is a quality person. It will do the testing, then it will go to the production side. My production in the sense your user or your customer side. Then self check. To compile a program means to translate it into English, translate into a binary code, pile up the bunch card used for the program, run the program as it was written. See, translate into English, simple compile a program, then translate into binary code. It will compiler will do these things. Pile up the punch cards used in the program and then run the program as it is written. It will go start to until in. It will do not go line by line. Pseudocode, self check pseudocode. Pseudocode also need to check your self check. The program as it is written in the programming, the result of the program that makes secret codes, the logic of a program written in English, and the logic of the program shown in the charts. Whatever the pseudocode have you written, this is also you need to self check. Again, it will go to your reviewer to check. So basically, first you yourself you are going to check properly. So if you not find any issue the same way what I have told you, it will go to your reviewer, and the reviewer again it will check. Check symbols for calculation, what I have shown you previously. This all. The flowchart symbol shown you decision is this. See, initially it is for, this is for calculation and this is for decision. If else, look is the flowchart section below. If the variable x is greater than 5, then print first, otherwise this is the decision variable. If x, suppose some variable is there and variable is greater than 5, then if it is true, then print first, otherwise print k, like that. It is a simple decision. K will be printed. Variable x is, see, actually below, if the variable is 5, variable 5 in the sense variable is exactly equal to 5, but here x is greater than 5, so it is basically x is equal to 5, so it is x, we have declared x is equal to 5, and here it is showing x is greater than 5, so it is my mind is, it is no, it is wrong, my mind is false condition, so it will go n side and it will print k. K will be printed. The answer is of question is x is greater than 5 is no, since x is equal to 5, not greater than 5, so it will go n side and is no, true or false side, so it will print k, like that. Self check, choose the correct flowchart symbol for each of these statements. Age is greater than 65, calculate text, start, print name, like that. Self check, a function in a program is sometimes from trigonometry like cos, sine. A subprogram usually performing one task. A way to check accuracy of a program or function check. Function check is basically it will check your functionality, what you have done, it's either right or wrong. I have something which is, I will show you. I want to show you something over here before moving ahead. I want to show you some of the programs what I have written So after that we will finish that part, whatever the remaining part, but that is not much. See, actually this is the adding of two numbers in a C language, which is very old. It is, do you remember, while I have shown you the chronology, it started in 1972. So there is basically the C language, this first language where now still it is using nowadays in most of the organization. So C is what? C. While we are writing some program in a C, so initially we will start with the include studio.h. Studio.h here is nothing but a library file. So all the functionality what we have written over here, it has been stored in stdio stdio dot io, in the sense input output. Std stands for standard input output dot io. It's called the library file. This is the library file. This is the library file. So each and everything, whatever we have written, these commands, printf, scanf, printf, so these things already have written in the these print functionality, printf and scanf has inside the library file. Otherwise, this code will not be run. So how we have started over here? See, first we have seen the include standard IO. Standard IO, what I have told you about. See, this is the way we are writing the program in C. We are initially using hash, each and everything, then include, word include in the standard library file we have to include. Then we are writing int main. Int main functionality. This is the main functionality. We have write open bracket and then it is closed, integer main. Then we have, see, actually we need to write we need to add numbers. So here we have taken int. Int is a stand for integer, which is numbers 1, 2, 3, 4, 5, 6, like that. Here we have written int abc. Int abc, what it will do? We have taken 3 variables. Why we have taken 3 variables here? Because basically 3 numbers, in which first 2 numbers a and b we have taken for 2 numbers like 1 and 2, because we need 3 variables. First variable is for first number, second variable is for second number, and third variable is basically for result, where we are going to keep those add number. While we are adding number 1 or 2, then 3 should be add somewhere else. 3 should be keep somewhere else, so that those data go directly to the memory. Just like after that we have declared the variable, then we have write the function called printf. Printf, what will do? It will print the number. So enter 2 numbers to add /and. So here it will ask you to enter 2 number. While you are executing this program initially in the C editor, it will ask you to enter 2 number to add. So it will ask you enter 2 numbers. So you are going to write here 3 and suppose 5. You have write 2 numbers in the output, 3 and 5. So what it will do, it will go over here again, it will give you 3 and 5. It will show you the scanf, it will give you 3 and 5 over here also. Then it will come to here, your functionality, what the functionality you are using here. So it will 3, it will add 3 to 5, which is what? It's become 8. So we have taken as 3 and B we have taken as 5. So what it will do? It will take 3 plus 5. It will add those things. A plus B. A plus B is nothing but 3 plus 5. Then it will keep those record, addition value 8. 5 plus 3 is equal to 8. So what it will do? It will, here if I am going to show you these things, so it will equals 8. So here what I am doing, I am exactly doing the same what the program is doing. So 8 becomes C. 8 the value come into the C, and A plus B, A is value 3 and B is value 5. So it will add 5 and 3 and it come 8. So 8 directly will put in the C. Then print F the entered number. Sum of the entered number is equal to hash dn. So whatever C. So here it when you are going to write these things, after that it will show you the result 8. Finally you will get the 8. Number 8. This is the way we are doing. This is the way my mind to say computer is doing the work, their job background in the backside. So this is basically we have done for C language. Then again if we are going to learn, then we are in the form of C++. C++, initially I have told you, this is the OOPS, object oriented programming. It follows the object oriented programming concept. The same here, it is the what do you call, library function, library files. This is library function file. So IOStream, what it will do, header file, which is also called the header file. IOStream, input output stream, the same there. stdio.in, here is IOStream input output. The using namespace standard, int main, which is also there, int main. Then same thing, integer variable abc. Here is also we can see that abc, I have taken the 3 variables. Then cout in the sense enter 2 number. The same what we are doing there, printf. We are using their printf. Here we are using cout. Here we need to write 2 numbers. Same thing, we are taking 3, 5, and again it is 3 and 5. What there we are doing std standard f, and 3, 5 printf, and then standard f, what we have seen those functionality over there. Then same thing, it will become 8, 3 plus 5, 8. Then cout, some of the number become 8. Then it will show you the print 8. Here you can see it will show you in the output 8. Sum of the entered number is equal to #c. C is nothing but your 8. What the data has 8, it goes to the capture into the C variable. So C variable show you in the output, which is nothing but 8. So here sum of the entered number, it will show you the 8, which is here. You can see over here C, we have written over here C. This is nothing but your output, your result. So result is in C, and it will show you result. Return 0 means your output. If return 0 in the nothing but if your output is perfect, I mean to say it is properly calculating your output, so it will return 0. Otherwise, it will give you the error. If you are not writing the proper code, so it will show you the error. This is the way we are writing the C++ programming. So there is not much difference you have seen in C and C++, only the difference in the functionality and this library file, function file. That's it. How we are writing, that is the same thing what we are doing in the C. Again we are going to another programming concept called Java. See, this is the way we are writing the program in the Java. Here is also we are using the import Java utility scanner. UTIL is nothing but utility. This is the file we are going to importing. My mind is importing the value. So here we are using the concept called class. Basically this class is nothing but it's a OOPS programming concept. OOPS is object oriented programming concept. This is object oriented programming concept. This is the object oriented programming concept. Here we have using public static void main. This is the functionality. We are using additional in Java, public static void main, and then args in the bracket open and close. Then here also we are writing the same, taking same value xyz. So here the same thing we can ask you that we have taken the x or y value, which is 3 and 5. Then we have read system.out.println. See, in the first C we have used printf. In the second we have C ## greater than sign. and here we are using system.out.println. This is the third way of entering two number in the print program and their sum. So here it will take the number 3 and 5. The scanner in, the new number is scanner in. So this is some different functionality for numbering. Then we have right over here x and y. So here we have to write the number x and y. What is the number of x and y? Here we are taking 3. Here we are taking 5, 3 and 5. Then system dot, then output. Finally we have to show the output. Here it is print the output, which is nothing but 3. Oh, sorry, one second. Here we have written the code for how to calculation. So 8 is equal to 3 space plus 5. Here it is in calculation for 8. It is equal to, and then here we are writing the for 8. It will print the value 8. This is the way the Java is doing their programming. The same is nothing much difference, but here we are the variable what we are writing. So we have to write in dot next int, int is an integer. Then again y is equal to in dot next int, again second integer. Then here we are writing z is equal to x plus y. We are adding these numbers. So 3 plus 5 is equal to 8, which we are going to 8, and it will directly capture by z. So z, it will here system.out.println. It will show you the, when you are executing the program, it will show you directly the output. So the way it is, when you are going to execute this program, it will ask you first enter the two integers to calculate their sum. It will ask you these. It will ask you this. Initially, when you give two numbers 3, 5, so it will directly show you the result. Sum of the it will like this, sum of the integer is equal to 8. It will not show this, in place of z it will give you 8. So it will directly show you the output value, which is 8. This is the way we are doing the Java. Here we have used the class concept. Class it's a kind of function, it's a kind of functionality which we are using in a object oriented programming concept. So this is nothing but a programming which I have told you. So the same way, little bit difference here and there. Just like here we have used the public static void main, which we are not using on C and C++, and then the declaring functionality to declare define the output is something different with the C++. Here also defining system.out.println, which is something different. And now I have I'm going to show you the last one, which is SAP ABAP. It's nothing but it's an ERP. It is one of the simple. I think we have gone through the C. We have seen the C++ for adding two numbers. We have seen the Java. Now I can say that this is one of the simplest way to add two numbers in SAP ABAP. ABAP is nothing but advanced business application programming. It's a business programming, which is nothing but ERP. So here what we have done, we have declared the data. Data is nothing but your values, data value. I mean the data types. So here we have taken value CA. CA is nothing but the variable 1, which is type I. I stands for integer, which is I will write over here 3. And then CB, this is the second variable, type I. I is equal to same. Second variable. CD. CD is nothing but your result. The result moment is the final variable where we have to put our data or keep our data. That is also type I. So what here we are doing, here we are not declaring the value while executing. Here we can directly declare the value in the program itself. Here we can directly declare the value in the program itself. Whatever the value we want to add, we can declare over here only. There is no need to execute the program, then write that those two numbers, then we show the result, then we take the result, or we can see the result. Here we can directly give the values directly over here with the help of while writing the value 3 and 5, and here what it will calculate 8 is equal to 3 plus 5. So it will calculate the value. 8 is equal to 3 plus 5, and when write, we are using the simple write statement, which is basically calculate the value and will show you the result 8. So it will not give you, it will, when you are going to execute this program, it will directly show you the result 8. There is a way to write the same calculation program, what the way we are write in the Java or some other language. There we have not given the value 3 and 5 directly inside a program, but here in the SAP app we can give the same thing inside a program. But the same way, if you do not want to write this number in the program, there is the way where we can write these things. Then the same way we can do, we have to write, we have to in the right form we have to write these variables, and then again after that in the result again we have to write one variable, and over there we have to write result variable. In the SAP app again we can, there is another one form in which we can give some parameters, I mean to say input buttons, where you can write 3 and another if you write 4, and we will give one button. When you're going to click on that button, it will show you the result 8, like that. We can also do that. So a single program you can write different way. So you have to think logically while writing your program, logically to thinking. So you can write your program in a different way. In a different way. So back to the self check. See, again, a function in a program is something from trigonometry like cosine, which is called a subprogram usually perform one task. A way to check the accuracy of a program, a function check. See, in a program we can write subprogram also using a local variable. What we have what we have already used, the local variable and global variable. Global variable we are declaring in the main program, and local variable we can declare inside a main program for subprogram or for some function and subprogram, and perform one task. The way to check the accuracy of the program. If you are writing something in a subprogram, it is very easy to understand the functionality of that program, very easy to understand the function check of that program. Those things we can do very easily. Self check. A variable is a program. Now we have to self check also variable. A variable is a program, a letter or word that represents a place to store data. Basically, a variable is nothing but where you can store a data. Just like I have shown you, I have taken the 3 variables in all the program. I have taken 3 variables A, B, and C. In each variable, we are storing some number. Here we are storing number. Basically, number is nothing but a data. So you can store a data in each and every variable. A decision made within a program. While using that variable in your code in your program, you can make a decision. You can write a code like that. A small subprogram used to find errors. This is very important. What I have told you about, a small subprogram is used to find errors. If you are writing a program in a code, I mean to say in segregated codes in a smart sum program, some part just like you have written the addition, then multiplication, then subtraction, then division. So if you are getting some error in decision part, in your multiplication part, so you don't need to write entire program. So you can look into the, I mean, it's a multiplication or division part where you are exactly getting the error. So this is called the subroutine. This is basically called the subroutine or subprogram. So in each, a big program is a part of small chunk of program, small chunk of subroutines where you can write your logic, or you have written your code. The challenges, what we are getting the challenges while we are writing the program. These things we have to understand. Try to write pseudocode and create a flowchart for a program and calculate the average of three grades and prints the average. The word good should be printed only if the average is more than 80. This is the simple. Try to write a pseudocode and create a flowchart of a program that calculates the average of three grades and print the average. See, suppose I have written this because I want to tell you that how we can think, how we can interpret while writing a pseudocode. See, try to write a pseudocode and create a flowchart of a program that calculates the average over three grades. Average over three grades, I mean to say, I mean to calculate the average of three numbers. Suppose I need to calculate the average of 1, 2, 3. 1, 2, 3 is nothing but 6. 1, 2, 3. It's a 6. 1 plus 2 plus 3 divide by 3, it's become 2. 1 plus 2 plus 3 is nothing but, if you are going to calculate 3 by 3, 6 by 3 is equal to 2. If I want to, I will show you in a quick manner. There is a 3 number, 1 plus 2 plus, 2 plus 3 divided by this is 3 numbers, so it will divide by 3, so it become it will show you the result 2. 1 plus 3 is 6. 6 bit divided by 3 because it's 3 number, so it will show you 2. So how to write a pseudocode for this, to make program for this things, how to write a pseudocode. So initially we have to take the same, get the 3 numbers, get the 3 numbers, add those 3 numbers, divide those 3 numbers by 3 because we have taken 3 number, divide by 3, and add print the result and end, like that. The simple way to write a pseudocode, what we have seen already. The word good should be printed only if the average is more than 80. Okay, good.